Good morning, everyone. This video is to review the concepts learned in the last class about the calculus enrichment that we were doing. So recall we have a picture and our goal is to find the slope of the tangent line at this specific point x. So we want to find the slope or rate of change of the function precisely here at x. And so the only way we could come up with was to find another point on the function that was h units away from x, to draw a secant line that connects the 2 points, and to find the slope of the secant line and let the secant line slope slowly approach the tangent line slope by letting h go to 0. So just a quick review. If I want to calculate the slope of the secant line, and remember, importantly, that is called the difference quotient. I would simply calculate slope between the 2 points. So I would do f of x plus h minus f of x, this is my change in y, all over x plus h, right? That's my x2 minus x. But remember we said that the denominator can simplify, the x's would cancel to just h. So here is our specific formula for the slope of the secant line, or the difference quotient. However, we said the slope of the secant line was horribly inaccurate, right? The slope of the secant line is way steeper than our desired slope, which is the slope of the tangent line. So the idea was to slowly let the slope of the secant line, right, approach the slope of the tangent line by putting these points closer together and by taking the limit as h goes to 0. If h approaches 0, these points are going to be so close together that the slope of the secant line and the slope of the tangent line will be virtually identical. So the slope of the tangent line is otherwise known as the derivative of the function. And remember that we denoted the derivative with this notation here. The way we figure that out is to take this formula and just amend it slightly by taking the limit as h approaches 0. So if we let that distance approach 0 and let the secant line approach the tangent line, we will have an accurate formula for rate of change. And that is still f of x plus h minus f of x all over h. So again, it's really just the slope formula in fancier notation. So I hope that helps. In the next video, I will start to talk about how to find the derivative of a cubic function.